So this question is coming from Feb March 22, paper 3 variant 2, and this is the fifth question of that paper. We are given two angles alpha and beta such that they lie in between 0 and 180 degrees, and we are given two equations, tan alpha plus beta is equal to 2 and tan alpha is 3 times of tan beta. We have to find the possible values of alpha and beta. So whenever they say possible values, it means there might be more than one values for each alpha and beta. So let's try to think about this. We are given two different equations over here. This is my equation 1, this is my equation 2. So from the first equation, I can use tan A plus B formula so that I get tan alpha plus tan beta and then divided by 1 minus tan alpha tan beta. And then I can use tan alpha is equal to 3 times tan of beta, substitute that into this equation and try to first solve for beta. Once I'm having the values of beta, I can put it over here and then solve for alpha. That is the process that I'm going to follow. I think that is going to work. So let's get started. I'm going to expand this formula and it's going to become tan of alpha plus beta is equal to 2. I'm starting from this point. So tan alpha plus tan beta divided by 1 minus tan alpha tan beta. This is equal to 2. And now I'm going to use the fact that tan alpha is 3 times of tan beta. So this is 3 tan beta plus tan beta is 4 tan beta on the top. And on the bottom 1 minus 3 tan beta into tan beta. That is 3 into tan square beta. So 1 minus 3 into tan square of beta. This is equal to 2. And I'm just going to write a reasoning that this is because, this is the symbol for because. I know that tan alpha was is equal to 3 tan beta. I am writing this condition or the reason so that examiner knows from where have I got to this equation from the previous one. But yeah, now we can go ahead and try to solve the quadratic in terms of tan beta to find the value of beta. So it's going to become 4 tan beta is equals to 2 minus 6 tan square beta. And if I just convert everything on the, I'll just shift everything on the left hand side and divide it by 2 so that it looks good. So it's going to become 3 tan square beta plus 2 tan beta minus 1 is equal to 0. Now I can use CAIE to find the values of tan beta. So let me open my CAIE over here and I'll be getting mode 5 3. So in this I'm going to get A as 3, B as 2, C as minus 1, and I got tan beta as 1 by 3 and minus 1. So I got two factors, 3 tan beta minus 1 and tan beta plus 1. Now I can go ahead and solve using ASTC for the values of beta. And please note that the value of beta and alpha both is in between 0 to 180 degrees. So if I draw my ASTC diagram for both of the options, I know my tan value is positive in my first quadrant in between 0 and 180 degrees. So this is simply tan inverse of 1 by 3. And tan is negative in the second quadrant. So this value is going to become beta 2. This is beta 1. So beta 2 will come out as 180 degrees. From 180 degrees, I'll get rid of this smaller angle, which is nothing but tan inverse of 1, which is 45 degrees. So I can say that, therefore, beta 1, I'll use my CAIE over here. I'll make sure my CAIE is in degrees mode. Yes, it is. Now shift tan inverse of 1 by 3. This comes out as 18.4, correct to 1 dp. And my beta 2 will come out as 180 minus tan inverse of 1. Tan inverse of 1 is nothing but this angle over here. So I'll get 135. 180 minus tan inverse of 1 is 135 degrees. So from here I know what is my beta 1 and beta 2. There are no other possibilities in between 0 to 180 degrees for my beta values. Now let's go ahead and try to solve for alpha. One time I'll put beta as this value and try to solve for alpha and see how many values I get over there. And same thing I'll repeat for beta too. So I don't have enough space over here, so no problem. I'll just get rid of the space from the top and yeah, try to solve for alpha. I know that my 10 alpha is equal to 3 times 10 of beta 1, and I'll use the full value of beta 1. I won't be using correct to 1 dp only. So my 10 alpha will come out to be, I'll use my calci for this, 3, 10. Beta 1 was 10 inverse of 1 by 3. I'll just cross check. Yeah, it was this only. If I do this, I am getting 1 over here. So 10 alpha is coming out to be 1. Now if I draw my ASTC diagram over here for this, my 10 is positive in the first quadrant in between 0 to 180 degrees. So this is simply 45 degrees. I know that 10 inverse of 1 will be 45 degrees from here. And the other thing you can do is 10 alpha is equal to 310 beta 2. So this is same as writing 10 alpha is equal to 310 of the beta 2 value was exit. So I'll just write 10 of 135 and it will come out as minus 3. Now using the ASTC diagram, I know alpha 10 alpha is negative in the second quadrant. So this is the value of alpha 2. Let me call this as alpha 1, and alpha 2 will be 180 degrees minus 10 inverse of this angle over here, 10 inverse of 3. So let's see what is the value that we are going to get over here. Correct to one decimal place. 180 minus 10 inverse of 3. Just checking if my calc is in degrees mode. Yes, it is. So I got 108.4 correct to 1 dp. 108.4. So here are my answers. In between 0 to 180 degrees, I got two values of the alpha, and with respect to that, I've also got two values of beta over here. This becomes my final answer. And you can always cross check this by substituting the values of alpha and beta into this equation. Always use the correct pair, only then you will get this answer over here. If you have got alpha 1 45 by using beta 1, use alpha 1 and beta 1 over here. So if I use my calc to see this, if I'm getting approximately 2, so 10 of alpha 1 was 45 and beta 1 was, I think, 10 inverse of 3 by 1 by 3. So this is coming out as 2. So it means that yeah, we are doing good. Let me check the other pair. 10 of alpha 1 was 108.4, or you can use this exact value, plus beta 2 was 135 degrees. So this should come approximately 2. Yes, 1.996 is approximately 2. So yes, even this pair is going to be the correct answer over here for us. So yes, we are done with this question.